Using TINACloud for analysis of pitfalls related with the feedback capacitor in low-pass filters. Adding a capacitor in parallel with the feedback resistor of an op-amp is an easy way of accomplishing low-pass filtering. This technique works quite well in an inverting amplifier, but not necessarily in a non-inverting amplifier. If the non-inverting amplifier has high gain, the filtering is not bad, but inferior to the inverting case. We will illustrate the above by creating and analyzing both circuits. Let's see how to create these circuits using the SPICE model of the OPA 132 operational amplifier using TINACloud. Log in to TINACloud. Create the circuit like the one on this sample schematic. First, save the file using the Save As command. Note that the program automatically saves the changes into this file while we are editing. Click the SPICE Macros tab at the Component toolbar. The toolbar of the SPICE macro components will appear. Next, click the Operational Amplifiers icon. The list of the available operational amplifiers from different manufacturers will appear. Select Texas Instruments. You can now select the op-amp OPA 132 from the list, or enter the part number into the top left search field of the dialog. Enter OPA 13, then click on OPA 132 and press OK. The selected IC will appear attached to your cursor, and you can move it anywhere by moving the mouse. Place it by pressing the left mouse button. Click the resistor icon on the basic component toolbar to place two resistors, R1 and R2. Position the symbols by using the mouse, then left-click to place them. Next, add the feedback capacitor. Add the two batteries, V1 and V2, and the voltage generator. In this case, we will use jumpers. V1 should be rotated by 180 degrees. You can rotate parts even before you place them by clicking the Rotate Left or Rotate Right icons. You can also rotate components after they are placed. Next, select the voltage generator. Then, from the special toolbar, select the jumpers. Add the grounds from the basic toolbar. Now you can wire up the circuit. Next, add the output to the circuit. Select the voltage pin from the meters toolbar. Connect jumper J1 with the op-amp in order to provide the negative supply voltage. Click J1, then press the Copy/Paste icons on the toolbar. Place the copy of J1 called J4 on the screen. Next, rename J4 into J1. Double-click J4, and in the Properties dialog, enter J1 into the Label field, then press OK. Connect J1 to the OPA 132 by clicking J1, then holding down the left mouse button while moving the mouse. Position and rotate a few component labels by clicking the label first, then holding down the left mouse button. After you place it, just click an empty spot on the workspace. So far, the components were inserted using their default values. Double-click the component, and the Property dialog will appear. Enter the required component value, then press OK. Double-click the R1 and enter 100K ohms into the resistance field. We should set the stepping parameters for R2. Double-click the R2 resistor, and in the Properties dialog, click the three dots, Details button in the resistance field. Select Parameter Stepping at the top of the dialog window and set the stepping parameters for R2 as shown next. check the stepped parameter checkbox, set the sweep type to logarithmic, set the start value to 100, the end value to 100K, and the number of cases to 4. Next, set the parameter values for C1, V1, and V2. Rename V1 to V- and V2 to V+. Set the signal of the voltage generator from unit step to sine wave. Rename J1 to V-, J2 to V+, and J3 to V-in. Next, we will recreate the inverting circuit. As the two circuits are similar, we will edit and copy the non-inverting circuit and then modify where needed. First, move the jumpers and the related supply sources to a better place. Click the multiple selection icon on the toolbar, then use window selection. Next, click a component by holding down the left mouse button. The selected components will be attached to your cursor. Position them by moving the mouse, then left-click to place them at the new position. Finally, click an empty spot on the workspace to deselect the components. Now, click again the multiple selection icon on the toolbar, then use window selection. Next, click the copy-paste icons. The circuit will be attached to your cursor. Position it by moving the mouse and holding down the left mouse button. Finally, click an empty spot on a workspace to deselect the components. The component labels are renamed, but as we can easily check, the component values remained the same. Click the resistor R4. It has the same value as R1. You can rename it to R1. Delete the ground attached to R2 and connect V-in to it. Delete V-in attached to the plus terminal of the op-amp, then add the ground to it. Now the circuit is ready for testing. In order to step R2, set parallel stepping in the Mode dialog under the Analysis menu. This will step both R2 resistors parallelly. Select Mode from the Analysis menu, then in the Analysis Mode dialog, select Parameter Stepping from the list. Next, select Parallel Stepping from the Stepping Mode list. We will test first the non-inverting circuit. Click the output voltage pin of the non-inverting circuit and set the display signal to Yes mode, or check if it is already set so. Next, click at the output voltage pin of the inverting circuit and set the display signal to No. From the Analysis menu, select AC Analysis, then AC Transfer Characteristic. For the lowest curve with a gain of 6 dB, the stop band attenuation is 6 dB only. Now test the inverting circuit. Set the display signal of the output voltage pin, Vout, of the non-inverting circuit to No. And change back the display signal of the output voltage pin of the inverting circuit to Yes. Then run again Analysis, AC Analysis, AC Transfer Characteristic. All curves exhibit normal 20 dB decade stop band attenuation. Now add this diagram and a title to the schematic editor window to store them together with the circuit schematic. Close the diagram window. Note that it remains available in the program. Use the Zoom Out command to make more place. Pan the circuit by holding down the left mouse button while moving the mouse. Select Insert Diagram from the Insert Plus menu. Select AC Ampli 1 from the list. You can edit the diagram size, then press Insert. The diagram will appear attached to your cursor. Position it and then add it to the circuit diagram by pressing the left mouse button. Add the title by using the Insert Text T icon. In the text dialog box, enter the title, then click the Properties button. Select a larger font and press OK. The title text will appear attached to your cursor. Move it to the middle at the top of the screen and place it by clicking the left mouse button. This concludes our demonstration of using TINACloud for analysis of pitfalls related with the feedback capacitor in low-pass filters. For more information, visit our website at TINACloud.com. Visit our YouTube channel, youtube.com/user/TINA Design Suite.